Okay, I wanted to work some of the problems out for you to kind of demonstrate how to solve the problems from Chapter 12. Like in the past, I'm basically just doing some of the problems that you will find on the worksheet within the textbook. So basically, I'm on page 187, Chapter 12 worksheet, and I'm just going to go through and demonstrate to you how to solve problems using dimensional analysis. So basically what we have going on here is we have a lot of scenarios, and the physician's ordered a certain medication in a dosage, and our dosage is usually different that we have on hand. And so we're just trying to solve to see what exactly we're supposed to get. So for number 1 on worksheet, chapter 12, it states, your patient with diabetes receives glycoside 10 milligrams every morning, PO, by mouth. The drug is applied in 5 milligram scored tablets. How many tablets will you administer? So over here, I kind of already have my equation set up for you. So when you're answering these questions, it's really important to first identify exactly what the question's asking, or what is it that you're solving for. So in this question, we are to solve or to identify how many tablets we want to administer. So we're solving for tablets. And so here I have tablets written out, because that's what we're solving for. The next, or the first step in your equation, and you'll notice that these are all set up in fraction type format. The very next thing that you will place is the dosage of medication that you have on hand. So on this one, the doctor has ordered glycoside 10 milligrams. We have glycoside 5 milligram tablets on hand. So again, since we're solving for tablets here, when I set up my fraction here, the numerator is going to be what I'm solving for. So it's going to be tablets up here. And I know, according to my dose on hand in this little scenario, that 1 tablet is 5 milligrams. Then we are going to multiply it and set it up with our next little fraction equation over here. And since I have 5 milligrams here, I want to make sure that I put my next milligrams over here so eventually they can cancel each other out. The milligram part can cancel each other out. So the doctor's ordered 10 milligrams every morning. So I have 10 milligrams over 1. And then after you've set that up, you can just kind of cancel out these labels, and you just multiply straight across the board. So 1 times 10 is 10. 5 times 1 is 5. And then you just divide 5 into 10 and equals 2. So the answer is, and this was an easy one, you probably didn't even have to work it out to identify the answer. But if I am to give glycoside 10 milligrams and I have 5 milligram tablets on hand, I'm going to give 2 tabs. Whoops, you're not seeing that. I'm going to give 2 tablets to equal that dosage. Very simple. They get a little bit more difficult. So the next one's number 2. This one is Mr. Thiessen receives Visceral 60 milligrams PO, which is by mouth, every 6 hours for relief of nausea after his acoustic neuroma revision. Visceral oral suspension, 25 milligrams per 5 ml is what's supplied. It's our dose on hand. How many milliliters will the nurse administer? So again, pay really close attention to what you want to solve for. And here we're wanting to know how many milliliters the nurse is going to administer. So I've set my equation up just like that. How many mLs am I solving for? With my first fraction, I know since I'm solving for mLs, the numerator is going to be the mLs of the dose I have on hand. The dose I have on hand is 25 milligrams per 5 mLs. So I put my 5 mLs here, and I know that there are 25 milligrams in that 5 mLs. Then up here, the dose that's ordered is 60 milligrams. So I put my 60 milligrams on top, so these can cross each other out, and then you just multiply straight across. So let's see here. 5 times 60 is 300 over 25. And then you just divide 25 into 300. 20. Whoops. Get 12. So I'm going to give 12 mLs. 12 mLs of a 25 milligram suspension is going to equal my physician's order of 50 milligrams of visceral. The next one, number 3. With this one, it says a patient who has undergone a lumbar laminectomy receives Demerol 0.025 grams PO every 4 hours, PRN for the relief of pain. Demerol 50 milligram tablets are what we have on hand. How many tablets will the nurse administer? So again, I'm solving for tablets. I want to know how many tablets I'm giving. So I have written tablets right here. And my dose on hand is 1 tablet has 50 milligrams in it. So that's how I've set this up. Again, my numerator's tablets because I'm solving for tablets. And 1 tablet has 50 milligrams of Demerol in it. Now, you'll notice that the physician has ordered the dosage of Demerol in grams, and we have milligrams on hand. So we're going to have to go back to your conversion sheet, and you just simply then set up the conversion of grams and milligrams. So here I have 50 milligrams. So over here on the numerator of this fraction, I want to put how many milligrams are in 1 gram, or vice versa. So I have 1,000 milligrams is in 1 gram. So I've got milligrams here. I've got to make sure that I put milligrams over here on this numerator so eventually I can mark them out when I go to multiply across. So then I have my 1,000 milligrams over 1 gram. So then I want to make sure that I put the physician's order over here, putting grams on top. Do you see how the labels should kind of go across from each other, the bottom and then the top? So here I had milligrams on the bottom. I want to make sure I have milligrams on the top here. I have my gram down here, so I want to make sure I have my gram put on top over here so they can cancel each other out eventually. Anyway, my physician's order was 0.025 grams. So now we're just going to multiply straight across. And 1,000 times 0.025 equals 25. And I'm going to divide that by 50. And I know it essentially ends up being a half a tab, or 1/2 tab. Okay, let's do some more. We'll kind of skip over and we'll do number 7 really quick. Okay, so number 7 states that Johnny receives Lanoxin 40 micrograms PO every 12 hours for the treatment of cardiac dysrhythmias. That's the dose that's been ordered. Lanoxin, the dose that we have on hand, is 0.05 milligrams per ml. How many mLs are we going to administer? So here's our equation. We are solving for mLs, and and the dose that we have on hand is 0.05 milligrams per ml. So I'm setting up my equation. Since I'm solving for mLs, I want to make sure that my first numerator is the mLs of the dose that we have on hand. So I have 1 ml, and 1 ml equals 0.05 milligrams. Now again, the physician has ordered this in micrograms, and we have milligrams on hand. So I know that 1 milligram is equal to 1,000 micrograms. Since I had milligrams here, I want to make sure that I put my milligrams for the numerator on this fraction setup. So 1 milligram equals, or is the same as 1,000 micrograms. Since I have micrograms here, over here the physician's order is 40 micrograms. So essentially, I have these set up so I can cancel my micrograms and my milligrams out. And now we're just going to multiply straight across the board. So this is 40 over, and we'll take 0.05 times 1,000 equals 50. And if I take 40 divided by 50, it equals 0.8 mLs. So in order to give 40 micrograms of the Lanoxin that the physicians ordered, the dosage that I have on hand, I'm going to give 0.8 mLs of it to equal that 40 micrograms. Next one. Number 8, the physician prescribes Stadol 1 milligram IV every 4 hours for a patient with a below-the-knee amputation. Stadol 2 milligrams per ml is what is available, or what we have on hand. How many milliliters will the nurse administer? So again, I'm solving for milliliters. And the dosage that I have on hand is 2 milligrams of Stadol per ml. So I'm setting up my equation like this. I'm solving for mLs. Therefore, my numerator on this first fraction is going to be mLs. And the dosage that we have on hand is 1 ml, or 2 milligrams. 1 ml has 2 milligrams of Stadol in it. The physician has ordered 1 milligram to be given. Kind of mark each other out, and we just go straight across. 1 divided by 2 equals 0.5 mLs. So we are going to give a half ml to administer the prescribed 1 milligram, which again, you could probably easily look at this and say, well, we've got 2 milligrams on hand per 1 ml. Half of that's going to be 1 milligram. But you have to show your work. So let's just make sure you're working it out like that. Number 9, the physician orders heparin 2,500 units subcutaneous every 12 hours for your patient with a jejunostomy. You have heparin 5,000 units per ml available. How many mLs will you give? Again, you could probably just look at that and know what you're going to do, but we're still going to work it out. So I am solving for mLs, and my dose that I have on hand is 1 ml equals 5,000 units. So I've got 1 ml is 5,000 units, and the physician has ordered 2,500 units. So how I've set this up, we can just multiply straight across. 2,500, 5,000 equals 0.5 mLs. Okay, when you divide that. All right, so now let's do some problems that have drips to it. Okay, so let's do number 11. Number 11 states, a patient with an infection has an order for Timitin 3.1 grams every 6 hours IV piggyback. The Timitin is dissolved in 100 mLs of D5W and is to be infused over 1 hour. The tubing drop factor is 20 drops per ml. At what rate in drops per minute should the IV piggyback be programmed? So with this one, we are solving for drops per minute. So I have that set up here, drops per minute. And therefore, I want to, since I'm solving for drops, the numerator of my first fraction has to be drops. And according to this scenario, I know that I have 20 drops per 1 ml. So that's how I've set up my first little fraction, is 20 drops is in 1 ml. Next, I want to solve, again, now I'm going to multiply that times my dose that's been ordered. Now, please pay attention here. It says that the patient has Timotin 3.1 grams ordered, but that has already been dissolved in 100 mLs of fluid. So we don't even need to do anything with that 3.1 grams. It's already in our piggyback. It's already in our bag of fluid. Essentially, all that we're trying to figure out is how quickly do I have to infuse, how quickly do I have to set my pump up to infuse this 100 ml bag in an hour? Right, I have a 100 ml bag and I want to infuse it in an hour, and I have a drop factor of 20 drops per minute. So that's why it's set up like this, and we're not even dealing with the Timotin 3.1 grams. It's already dissolved. We're just trying to figure out how quickly do we need to set our pump to get this bag of 100 mLs infused in an hour. So I've got a drop factor of 20 drops per minute. I have 100 mLs of fluid that I want to administer in 1 hour. And the answer is I'm trying to figure out how many drops per minute. Now this is an hour, so we know that there are 60 minutes in an hour. So to set up this next equation, I'm just putting, so these hours can cancel it out. You put your hour on top over 60 minutes. Now that was an extra step that you don't necessarily have to do. You could go ahead and change. You could go ahead and convert this 1 hour here to 60 minutes. You're going to get the exact same answer. I'm just kind of showing you how the book is showing you. But I know that there's 60 minutes in 1 hour, so I could have went ahead and just put 60 minutes here. But we set it up like we're supposed to, so everything can now cancel each other out. These mLs can cancel each other out, and these hours can cancel each other out. Now we're just going to multiply straight across. So 20 times 100 equals 2,000. Divided by 60 equals 33.33333. You can't give a third of a drop, so your answer is just going to be 33 drops per minute. Okay? We'll do some more. Number 12. Number 12 states a patient with anuria has an order for 500 mLs of normal saline to infuse over 2 hours. The tubing drop factor is 10 drops per ml. At what rate in drops per minute should the IV pump be programmed? So again, we have a 500 ml bag and we want to infuse it in 2 hours. And our drop factor is 10 drops per minute. So what are we going to have to set our pump at? What rate are we going to have to set our pump at to get this 500 ml bag infused in 2 hours? So we set our equation up just like that. Again, I'm solving for drops per minute. So I know that I have a drop factor of 10 drops per ml. And I want to give 500 mLs in 2 hours. And I want to, then here's this equation set up over here. We're just putting our hour over 60 minutes. Again, I don't necessarily have to do that one. I know that there's 120 minutes in 2 hours, so I could have just put 120 here too and not worried about this third equation. But again, this is kind of how the book shows you up, is setting up a whole nother equation. And it does this so you can, again, cancel out your labels. Now we're just going to multiply straight across. So 10 times 5,000 equals 50,000. And over 120. So 50,000 divided by 120. Oh, you know what? That's not right. Sorry, that's 5,000. I didn't think that looked right. 10 times 500 is 5,000. So you have 5,000 divided by 120 equals 41.6 drops per minute. I would probably round that up to 42. There's your answer. Okay, 42 drops per minute. The next one we'll do is number 13. A patient who takes Coumadin at home is admitted to the hospital before surgery to receive a regulated infusion of heparin. The heparin is ordered for 1,400 units per hour. The heparin bag concentration is heparin 25,000 units and 250 mLs of D5W. At what rate in milliliters per hour, so now we're going hours, we were doing minutes, now we're doing hours, should the IV pump be programmed? So we are solving for mLs per hour, and we have a 250 ml bag that has 25,000 units of heparin in it. That's the dose that we have on hand. One bag has 250 mLs of fluid with 25,000 units of medicine, the heparin. And we want to give 1,400 units per hour. So we're going to set it up like this. Again, we are solving for how many mLs per hour we're going to give. We want to give 1,400 mLs. We want to give 1,400 units. So how many mLs per hour is that going to be? Well, our bag of fluid is 250 mLs. And within that 250 mLs, we have 25,000 units. We're going to multiply that by the dose that is ordered. And what's ordered is 1,400 units per hour. So the units are going to cancel each other out, and we're just going to multiply straight across. So 250 times 1,400 equals and we're going to divide that by 25,000. Oops. And it equals 14 mLs per hour. So essentially what we just solved for is we have, the doctor wants us to give 1,400 units of, Coumadin to a patient in an hour. And the bag, the concentration of the bag that we have is 25,000 units of heparin in a 250 ml bag. So this is how we know of that bag, if we give 14 mLs per hour, it will equal 1,400 units per hour. Okay. All right, let's do a couple of more of these. Number 16, the physician orders dobutamine at 12 micrograms per kilogram per minute for a patient weighing 75 grams. The concentration of dobutamine is 1 gram in 250 mLs of D5W. At what rate in mLs or milliliters per hour will the IV pump be programmed? So we have a patient that weighs 75 kilograms, and the doctor wants us to give a dosage of 12 micrograms per kilogram per minute. And the concentration of dobutamine that we have is 1 gram and 250 mLs. Now what we're solving for is how many mLs per hour are we going to set the pump. So this is how we're going to set our equation up. Again, we're solving for mLs per hour. So the numerator of our first fraction has to be mLs, and that's the dose that we have on hand. We have a bag of 250 mLs of D5W, and within that is 1 gram of dobutamine. And again, my order is for micrograms. My dose on hand is in grams, so I'm going to have to do that little quick conversion, throw in that equation there, and I know that 1 gram is the same as 1 million micrograms. So I have grams here, so I'm going to put my grams on top over here. So, and that's just your quick little conversion guide. So you can go from grams to micrograms. Then the next one is the dose that's been ordered, and the doctor wants us to give 12 micrograms per minute. However, we are solving for hour. We want to know what to set our pump at. and we want to know how many mLs per hour we want to set our pump at. So we're going to take that 12 mics per minute and multiply it by 60, or convert it to 60. And then the last one is your patient's weight. This patient weighs 75 kilograms, and we are to give 12 micrograms per minute per kilogram. So we got our 75 over there for our kilograms. Once you have your equation set up and all the numbers plugged in like you need them to be, then the math is very simple. You're just going to multiply all the numerators together, multiply all the denominators together, and then you divide. So with this one I have, and it's probably going to be a big number, 250 times 12 times 60 times 75. That gives me 1, 3. Divided by 1 million. The answer is 13.5 mLs per hour. That is your answer. So again, we were wanting to know in an hour, what are we going to set our pump at? How many mLs are we going to give in an hour that is going to equal the dosage of 12 micrograms per kilogram per minute? So that's what the doctor, he will write his order like that. He wants us to give 12 mics per kilogram per minute. So then we have to go and do the rest of the math. We have to identify how many kilograms our patient is, which in this scenario that was given to us, our patient is 75 kilograms. We know that our dose on hand, the medication that we have on stock, is for dobutamine to be 1 gram of dobutamine to be mixed in 250 ml bag. Then we have to figure out the rest. And you don't set your pumps in minutes usually. Normally when you're setting your pump, it's mLs per hour. So although the equation, the physician gave us an order per minute, we then have to convert that to see how many mLs is that going to be in an hour. And this equation is how we set that up. We had 250 mLs, 1 gram mixed into 250 mLs. Here's our little conversion guide so we can go from grams to micrograms. The order was 12 mics per minute. However, we want to know how many mLs per hour, so we have our 60 minutes there, and then our patient's weight of 75 grams. We'll do one that's kind of similar, only this one doesn't have a weight to it. Number 17 is Mr. Perez is having chest pain and has an order for nitroglycerin at 10 micrograms per minute. The concentration is nitroglycerin 100 milligrams in 500 mLs of D5W. At what rate in milliliters per hour will the IV pump be programmed? Make sure you guys can hear me. Okay, so again, we are solving for milliliters per hour. The physician ordered us to give 10 micrograms per minute, and our dose on hand is 100 milligrams in a 500 ml bag. So since we're solving mLs here, our numerator is going to be our dose on hand with the mLs first. So our dose that we have on hand is a concentration of 100 milligrams of nitroglycerin in a 500 ml bag. So we got 500 mLs with 100 milligrams of medicine in it. Again, the physicians ordered this in micrograms, and we have milligrams on hand. So here's our quick conversion. I know that there's 1 milligram in 1,000 micrograms. And I set up milligrams on top, so I'll be able to cancel these out. Then your dose on hand, or your dose ordered, is 10 micrograms per minute. So I put my micrograms on top per minute. And again, that was what was ordered, was to give 10 micrograms per minute, but we're trying to solve for how many mLs per hour. So we're going to have to multiply this all by 60. So these two will cancel each other out. And then you just multiply straight across the board. So 500 times 10 times 60, it's 3, 1, 2, 4, 5. divided by 100 times 1,000. Okay, so 300,000 divided by 100,000 equals 3. So we're going to give 3 mLs per hour. If we give 3 mLs per hour of a concentrated bag that has 100 milligrams of nitroglycerin in 500 mLs, then that is going to equal our order of 10 micrograms per minute. And that's how we solve for that. The order is 10 mics per minute. However, we have to set our pump up to mLs per hour. And so we know that we will set our pump at to administer 3 milliliters per hour to this patient to give them the equation or the equivalent of 10 mics per minute. Okay. Now let's do 19. 19 has 2 parts to it, and I've kind of already set the equation up here. 19 says, calculate the acetaminophen dose range for a child who weighs 14.5 kilograms. The recommended dose of acetaminophen is 10 to 15 milligrams per kilogram per dose. So it's very simple. I have a child that weighs 14.5 kilograms. And the recommended dose is 10 to 15 milligrams per kilogram. All I have to do is take my 14.5 kilograms and multiply it by 10, and then again multiply it by 15, and that's your range. So 14.5 times 10 equals 145. And 14.5 times 15 equals 217.5. So the answer for 19A, Part A, is my range. My recommended dosage range is going to be between 145 milligrams and 217.5 milligrams. So as long as I stay within that dosage, every time I give this child a dose, then I'm going to be administering them a safe dosage. So B then asks, what milliliter range is needed to deliver the calculated dose range? Acetaminophen is available as a Tylenol elixir, 160 milligrams in a 5 ml bag. So we are solving for milliliters. Out of this bottle of Tylenol that has a concentration of 160 milligrams per 5 mLs, to stay in this safe range up here, how many mLs can we give? So to set that up, again, I'm solving for mLs. It states what milliliter range is needed. So I'm solving for mLs, and I know that my dosage on hand, the concentration of my dosage on hand, is 5 milliliters per 160 milligrams. Up here, I know that a safe dose is 145 milligrams. So if I wanted to give 145 milligrams to this child, how many mLs will I give them? And so we just multiply straight across. So 5 times 145 equals 725, then divided by 60, 160, is 4.5 mLs. So if I wanted to give this child 145 milligrams of this bottle of Tylenol that has a concentration of 160 milligrams per 5 mLs, I will give them 4.5 mLs, or 4.5 mLs. Down here, so then my top safe range was 217.5 milligrams to be given. So if I wanted to give the top end dose of this Tylenol, how many mLs am I going to give? So again, I have a concentration of 5 mLs 160 milligrams in 5 mLs, and I want to give 217.5 milligrams. So let's mark across. So 5 times 217.5 equals, and I'm going to divide that by 160. So here I could give, it looks like 6.8 mLs. Okay, so hopefully, you'll have some problems like this where you'll first have to identify what's a safe range of medication to give this child, and then, like with this one, you were given a bottle of Tylenol, and the concentration of that Tylenol elixir was 160 milligrams in 5 mLs. So if you wanted to give 145 milligrams from that concentration, how many mLs or milliliters will that equal? And then down here, we wanted to give 217.5 milligrams. So how many mLs of this medication will equal 217.5? And we came up with 6.8 mLs. Okay. Let's do 21. 21, I've kind of already went through and solved some of these. So, looks like I solved most of it. Okay, so with this one, it says Amoxil 500 milligrams is to be given PO every 6 hours for a child weighing 50 kilograms. The recommended high dose of Amoxil is 80 to 100 milligrams per kilograms in a 24-hour period, divided into 2 doses. So they want to give that dose into every 12 hours, or to give it into 2 separate doses. So here, the first one is, what is a single dose range for this child? Well, again, I want to give 80 to 100 milligrams per kilogram in a 24-hour period for this child. So basically, you're going to take your 80 milligrams and you're going to multiply it by the child's weight, and that's in a 24-hour period. So if you're going to give 80 milligrams per kilogram in a day's total, you can give up to 4,000 milligrams. And if you do the highest end of the 100 milligrams of the Amoxil, 100 milligrams times 50 kilograms is 5,000 milligrams. So in a 24-hour period, this is the maximum dose. However, we are to divide those doses into 2, or to give it every 12 hours. So basically, you just take 4,000 milligrams. If you divide it into 2 doses, each dose will be 2,000 milligrams. And if you divide it into 4 doses, which is basically what it was originally ordered, it says Amoxil 500 milligrams PO every 6 hours. Divide 24 into 6, it's going to be 4 times. So if I was to give a dosage of this concentrated 400 milligrams, then I'll give 1,000 milligrams every 6 hours. The other one up here, if I wanted to give the total, the maximum, the highest side of Amoxil, I have my 5,000 that I can give in a 24-hour period. If I divide that into 2 doses, I just simply take 5,000 divided by 2, and each dose will be 2,500 milligrams every 12 hours. And if I want to give it every 6 hours, then it's going to be 1,250 milligrams every 6. So that's kind of how you break it down. You have your maximum dose for the 24-hour period, and then you can just divide that into however many doses throughout the day that you want. And then the last one is the ordered dose safe to administer? And I would say, yes, the ordered dose is safe to administer. The order was to give 500 milligrams of Amoxil every 6 hours to a child weighing 50 milligrams. And we can do that. If we took 500 milligrams and we multiplied it by 4, which that would be 4 doses in a day, then that's going to give us 2,000 milligrams for the total day, which is in our safe range. It's actually on the low end. Okay, we got 2 more to do. Let's do number 23. Okay, so this one has 4 questions to it. And the scenario is the physician ordered Keflex 250 milligrams PO 4 times a day for a child weighing 50 pounds. You have Keflex 250 milligram capsules. The recommended daily dosage for a child is 25 to 50 milligrams per kilogram per day, and you want to administer that every 6 hours or into 4 separate dosages. So the very first one is, what is the child's weight in kilograms? So I have a child that weighs 50 pounds. So remember, you just take your 50 pounds and you divide it by 2.2 if you want to go from pounds to kilograms. And when I do that, I have it written out here, I have 22.7 kilograms. So that's your answer for part A. 50 pounds divided by 2.2 is 27.2 kilograms. B is, what is the safe recommended dosage or range for this child? So the recommended daily dosage is 25 to 50 milligrams per kilogram per day. So basically you just take 25 milligrams and you multiply it by your kilograms, 25 milligrams, multiplying it by our 22.7 kilograms, and that equals 567.5 milligrams, I think. And then we multiply our 50 milligrams by the weight. 50 milligrams times 22.7 equals. So this is our range for a 24-hour period. Again, it says the recommended daily dose, the recommended daily dosage for a child is 25 to 50 milligrams per kilogram per day. So 25 milligrams times their kilogram is this amount per day, and 50 milligrams times their kilogram is the top. This is the top end of the dosage for the day. Is the order safe? So our order was to give Keflex 250 milligrams by mouth 4 times a day. So if you take 250 and you multiply it by 4, you get, I think, 1,000. You get 1,000 equals 1,000 milligrams. So if we was to give this child 250 milligrams 4 times a day, they're going to have a total in a 24-hour period of 1,000 milligrams. And we know that's safe because that's within our range. So the answer to C is yes. It is safe because we are going to be giving a total of 1,000 milligrams. And if yes, how many capsules will you administer? Well, the physician's ordered Keflex 250 milligrams, and our dose on hand is 250 milligrams per capsule. So we're going to give 4 caps per day. 1 caps per dose, or 4 capsules in a 24-hour period. So I guess depending, you could put, if yes, how many capsules will you administer? I'll administer 1 cap per dose, 4 in my whole 24-hour period. Okay, last one. Let's do number 25, because this one is talking about milliunits and units. And I looked through the book and I did not see this equivalent, but 1 unit equals 1,000 milliunits. So that is your equation there. That's 1,000. 1 unit to 1,000 milliunits. So you kind of need to know that to solve these problems. So number 25, the physician has ordered 500 mLs of D5W with 10 units of Pitocin IV. That's what he wants us to give. We are to begin at 2 milliunits per minute and then increase by 1 milliunit every 30 minutes until our contraction pattern is regular. The maximum dose is 30 milliunits per minute. So that's what we got going on. let's just see what we're supposed to solve for. So A is, what is the IV rate for the beginning infusion? So at the beginning, we have an order to start 2 milliunits per minute. And so we have a bag. Imagine a bag of fluid. We have a bag of fluid that has 500 mLs in it. And mixed within that 500 ml bag, we have 10 units of oxytocin. And right now, I want to administer a dosage that is equal to 2 milliunits per minute. So this is how we'll set up our equation. I am solving for mLs per hour. Again, when you set your pump for how many mLs you want in an hour. You don't put it in how many mLs in a minute. That's not how the pumps work. So we are solving for how many milliliters an hour will we infuse this bag that is going to give my patient a dosage of 2 milliunits of Pitocin a minute. So to set it up, again, I'm solving for mLs per hour, so I'm going to put the mLs of my dose that I have on hand. So I have 500 milliliters on hand, and within that 500 milliliters, I have 10 units of Pitocin in it. I have units on hand, but I have an order for milliunits. So here is my conversion. 1 unit is the same as 1,000 milliunits. So I put my 1 unit on top, so eventually these can mark each other out. Now over here we put the dose that has been ordered. The ordered dose is 2 milliunits per minute. So I put my 2 milliunits on top, so these can mark each other out. Now again, I'm solving for mLs per hour. This is 2 milliunits per minute. Well, I want to know how much that's going to equal in an hour. So I will then multiply that by 60. So mark those out. And now you just multiply straight across the board. So I have 500 times 2 times 60. And that gives me 60,000. And I'm going to divide that by 10,000. And 60,000 divided by 10,000 is 6. So the answer is, again, to kind of tell you what this all means, is I want to administer 2 milliunits per minute to my patient. That's what the doctor's ordered. He wants us to give this patient 2 milliunits of Pitocin every minute. We have to figure out what that converts to with the medicine that we have on hand and how to set our pump up. So I want to know how many mLs per hour of this medication my pump needs to infuse to equal to a medication dosage of 2 milliunits per minute. I have a 500 ml bag with 10 units of Pitocin in it. I have units on hand. The doctor ordered milliunits, so here's your conversion. 1 unit is the same as 1,000 milliunits. So here is my dose that was ordered, 10 milliunits per minute, but I can't set my pump in minutes. I'm going to set my pumps per mLs per hour. So I'm going to take that and put 60 minutes over here. And it ends up being 6 mLs. And then the last one, what is the IV rate for the maximum infusion? So the dose, it says here that the maximum dose is 30 milliunits per minute. So if I keep setting my pump, keep increasing, and I get to that 30 milliunits per minute, how many mLs per hour is that going to equal? So how many mLs per hour, our maximum infusion, how many mLs per hour will the pump be set at to equal 30 milliunits per minute? So you're setting up your equation the exact same way. My dose on hand is the same, 500 mLs per 10 units. I have my conversion here of 1 unit is the same as 1,000 milliunits. My maximum dose that I can give this patient is 30 milliunits per minute. And since I'm solving for mLs per hour, I have to, this minute means nothing to me. I'm going to change it to 60 minutes, which will equal my hour. So then it's all set up, so you can just cancel out all of the labels, and now you multiply straight across the board. So again, 500 times 30 times 60, it's a big number, 900,000, divided by 10,000, equals 90. So this is 90 mLs per hour. Okay? So just again to clarify what we just did, the question was what is the IV rate for the maximum infusion? And on our little problem it says the maximum dose is 30 milliunits per minute. So I have a bag that has 500 mLs of D5W with 10 units of Pitocin in it. Here's my conversion. I have units on hand. The physician has ordered milliunits. So I'm going to put my conversion here of 1 unit over 1,000 milliunits. The maximum dose that I can give is 30 milliunits per minute, but I want to solve for mLs per hour, so then I'm going to have my 60 minutes over here to convert that in minutes to an hour. Multiply straight across. If I give 90 mLs per hour, that is the equivalent to 30 milliunits per minute. Okay, so that is an example of all of the different types of problems that you'll see on your worksheet that's due this week, and the different types of problems that you'll see on the test. And this is these are very real life scenarios. This is exactly what you're going to see when you get into healthcare. These exact types of problems where the physician has ordered a certain dose that doesn't perfectly match the medication dose that we have on hand. And so you'll have to do an equation to figure out, okay, how much of this medicine do I have to give to equal the dosage that the physician has ordered? So this is 110% exactly what you will see and do in practice. As always, email me, call me if you have any questions and you still are having difficulty figuring out this dimensional analysis way of solving dosage calculations.